Hello and welcome back. Today we will be making It's a useful reagent in organic synthesis because it can sometimes be used instead of aniline. For example, if you want to nitrate aniline directly with nitric acid, you get this result. But with acetanilide, you can protect the aniline and nitrate the molecule without troubles, unlike with the aniline. The resulted nitrated compound can be later hydrolyzed to acquire the nitroaniline. Therefore, acetanilide can be used for protecting the aniline and for many more other reactions. Historically, it was used as pain medication named as antifibrin, but today it's discontinued and replaced with other newer and safer medications like paracetamol. So now to make it, we need to acylate the simplest aromatic amine. This is aniline. To acylate something means that you basically attach an acyl group to a molecule. To acylate it, there are many ways, and actually, it can be done by almost any acetylating agent. For example, acetic anhydride, acetyl chloride. But you don't necessarily need that hard to get powerful acetylating agents. You can also use glacial acetic acid, and the reaction works just fine. But to speed it up and to make the yield higher, I also used a little bit of a catalyzer. I chose zinc chloride because it's easy to make and effective. So now let's finally start this synthesis by firstly making some zinc chloride. To do that, I just measured out some zinc powder to a small beaker. Then I poured in some hydrochloric acid, and it immediately reacts to form zinc chloride and hydrogen gas. Then I heated the mixture and let all the water to boil to leave behind just the zinc chloride. I wanted to record an epic crystallization, but apparently it stopped making crystals for some reason. Maybe the zinc chloride was pulling water from the air and redissolving. I don't know. Anyhow, this is our zinc chloride. I didn't need much, so this was enough. Now we need to measure out some aniline. I kind of eyeballed it, and I thought that around 70 milliliters would be enough. But keep in mind that aniline is quite toxic, so I did that carefully. Reaction vessel. I then added the zinc chloride coated stirrer and the measured aniline. Next, it was time to measure out our acetylating agent, glacial acetic acid. The glacial part was really obvious because all of the acid freezed inside a bottle due to its low freezing point of 16 degrees. It was then all poured into the aniline and catalyzer mixture. Another interesting thing that I observed was formation of needle-like crystals on the aniline dirty measuring cylinder's walls. It could have been acetanilide that is formed, or maybe aniline acetate. What do you think it could be? Then heating and stirring was started, and a condenser was added to reflux the mixture. The reflux was done for 2 hours. After 2 hours, I stopped the reflux and allowed the mixture to cool down. As it did that, the whole mix solidified due to all the product crystallizing out. The last step was to get this crude product out and wash it with a little of cold water on the filter. I also dumped the mix into some cold water to try to precipitate as much of the product as possible. Sorry for not showing the final product. I somehow forgot to film it. Anyhow, thanks for watching. Bye.